Hello everybody, I'm Mr. Gerald, and today I'm going to be going over how to solve basic kinematics problems using no formulas, only using a velocity graph. So all of the math in here should be pretty straightforward. The only thing you really need is to understand what slope is, slope of a line from Algebra 1, and how to calculate areas of basic shapes. And we can solve pretty much any kinematics problems that's thrown your way. So let's get into that right now. Here we go. Okay. So here's the problem that we're going to look at right now. This says that the initial velocity, the v at time 0 is equal to 6. And then 4 seconds later, v, the velocity, is equal to 18. Now, just for people that are watching that might not be in my class, as a default when we're talking about units, and I've said this in an earlier video, but I'll say it again at the outset of this series, the distance that we use is always measured in meters, time is always measured in seconds unless we say otherwise. So the unit on acceleration would be meters per second squared, and the unit on velocity would be meters per second. So v of 0 is 6 meters per second, and v of 4 is 18 meters per second. Now the question says find the acceleration and the displacement. So the easiest way to go about doing this is, as I keep saying in class, draw a velocity graph. Velocity graph is king. And it doesn't have to be beautiful, it has to be a sketch. So we'd say this, if this is v and this is t, v of 0 is 6. And then 4 seconds later, the velocity increases so that the total is 18. Okay, so let's see what we have here. Knowing that acceleration is nothing more than the slope of a velocity graph, this point right here is 4, 18. And let's not forget that this point back here is actually 0, 6. And if I calculate the slope of that line, that would simply be 18 minus 6 over 4 minus 0, the difference in the y's divided by the difference in the x's, which is equal to 12 over 4, which would be equal to 3. Okay, so now the numerical value for the acceleration, which is the same thing as the slope of this line, would be 3. And we know from class that that unit would be 3 meters per second squared. I'll make another video explaining better about the units if we need that, okay? But right now, the acceleration is just the slope of that line. That turns out to have a value of 3. What does that mean? Every second, the velocity increases by 3. So just going from my sketch, if we increase 1 second in the time direction, we increase 3 meters per second in the velocity direction. And if we do it again and again and again, it's going to be an increase of 3 for 4 seconds, which is an increase of 12. All right, so now let's take that. Now let's figure out what the displacement is. So let me just erase some of these things I just put in. Now to find the displacement, we only have to figure out what the area underneath the velocity graph is. So I would the way I could do this is, well, it's an odd shape. It's a trapezoid, in fact. But let's basically turn it into a rectangle and a right triangle. So this rectangle is 4 by 6, and this is 4. And since the whole entire length from top to bottom for VF, for the final velocity, is 18, that must mean this piece of it has to be 12, because the 12 and the 6 add up to the total 18. So now if I figure this area out, I've got 6 times 4 on the bottom rectangle, which would be 24, okay? And then on the top triangle, that's going to be the base. So 1/2 base times height is going to be 1/2 times 4 times 12, which is also 24. So the total area is 48 meters. Well, the total area is 48 square units, but we know that on a velocity graph, the area stands for the displacement. And there you go. We were able to figure out the acceleration and the displacement, and we really didn't use a single formula from kinematics.